Hi everyone. Today I'm going to help you with your workbook page 138 from the 3B workbook on area and perimeter. These are the questions. They are a little bit more challenging and requires you to be very familiar with your concepts of area and perimeter. So it will help if you have already revised what you have learned on this chapter so far before coming to solve these questions. As with the previous question, what I like to do when I start solving problems like that, and when explaining to you, I like to make copies of the question in hope to help you to be able to see better, see as in visualize the shape better by making copies and going through the process of, like here as described in question 2, cutting shapes. So if you like what I'm doing here, you can also make copies at home and go through the steps in this teaching video and see if they can help you to understand better too. Right, starting with question 2. So on this left hand side, you will see the original copies of the question. On the right hand side are the copies of the question I've made. I even snipped some of the questions out. So I'm going to look at question 2 now. I put my question 3 model aside so that it will not distract you. And let's take a good read of the question, following the steps of RACE, R-A-C-E, reading twice, making annotations, choosing a method, and evaluate. A small square is cut out from a 10 cm square as shown below. Find the perimeter of the figure. Okay. Now you see, one thing I like about area and perimeter questions is that it's got to do with visualization. So for some of us who likes shapes, you might find word problems from this chapter more enjoyable. And then sometimes the questions are not exactly very long, okay? But they can be sometimes. You'll see when it comes. So I'm going to read this again, and this is the part where you have to be extremely careful not to make the common mistake that happens in many of us, okay? Here says, a small square is cut out from a 10 cm square as shown below. Find the perimeter of the figure. Now what is the common misconception that can happen is from the word cut out from. Actually, these three words, cut out from. So you need to be able to understand that process and where does the measurement 10 cm appear? Is it the small square or is it the big square? The problem is, some of us, when we are looking at this picture here, might be able to see the small square. And no, I don't see the big square. Or some of us might be able to see the big square and we don't quite see the small square. Some of us may be able to see a L-shaped shape and some of us may not be able to see that. So this is one of the problems that may happen. Okay, so one of the things I enjoy about this chapter is being able to help me improve my visualization when I turn the paper around, and this may help me see better. So I get all sides of all views of the shape. So just now when I say L shape, man, you can see the L. Can you see that? Okay. Alright. Okay. Now on the right side, you see me making copies of the question. Alright. So what I mean is, some of us might be able to see the big square. That's a big square I'm talking about. Okay, this is shaking a bit. So let me just. Okay, that's my handphone holder that's shaking. So try to stabilize it a little bit. Okay, and that's the L-shaped figure. And this is the copy of the question. Right. So here, the small square. First, what you need to be able to do is to identify where the small square is. Okay. Cut out from. That's an important part. from a 10 centimeter square. So one of the problems is that misconception that can happen, thinking that this smaller square here has the size of 10 centimeter. Now if you are thinking this way, you are making a very important mistake. Okay, so this is the part where you have to be very clear. Now the question here says a small square is cut out from a 10 centimeter square. The small square here is not stated what is the size of the square. So there are no units of measurements written for this square. So in fact, you don't know how big that square is, how small that square is, how small is. So actually it's not this small square that's 10 centimeters. So that's the most problematic misconception that can happen when you're dealing with a question like that. So when it says a small square cut out from a 10 centimeter square, it actually means this big square here, this big shape here. To illustrate this better, I make the copy of that shape, and this is the square that is that is in the question. So I hope you can see this better as the square is. So I've cut out the shape as well, so you can see I'm flipping it around. So this is the shape, this is the square. And the next question is asking that I cut out that square, this small square here, I cut it out from this. So which in this case I can actually, let me just color it a bit more. Okay, this square here, this green color square, this space here, I'm going to cut it out. Okay, take note, this is the other misconception can happen from here. So when I cut it off, I'm cutting that space, that area of the shape, that area, that this part of that big square, I'm cutting it away. This is the small square. No dimensions given, I'm not so sure how big or how small this square is, but I chop it out. And that's how I got this figure here. The figure as mentioned, this is that figure, see? And this is the figure here. That's the process. So I'm asked to find the parameter of the figure, and if I use my highlighter now, the outline of this figure, I'm outlining it in orange, this is what you're being asked to find. Okay, so if you see here, the outline here is what I'm supposed to find, and that is a very important part. Not asking about the area of the figure, I'm asking about the parameter, the outline of the shape. So at this point, the first thing you need to understand is the question asked for the parameter. The next thing you have to understand is what is it that you have cut away from that big square. And that's this tiny small square here that's being taken away. Now because it's a square as well, you understand that all sides of the square is the same. Now of course, you can give an imaginary number that's smaller than 10, and that's the all sides to it, and you can find out these missing parts of the shape, because you know that this is 10 and this is 10, but you don't know these other measurements. It's not given to you because you don't know what's the length of this small square that's being cut out. But essentially, you need to the way to solve this question is to really truly understand the concept of parameter here. The most important thing is to realize that because it is the parameter we are asking, in fact, the parameter of this shape, this figure after that I've attained after I cut out that small square, has actually not changed from its original square shape. So actually these two shapes here share the same parameter. Really? How's that possible? It begins with this little square. Understanding this, all sides of this little square is the same. As with just now I said, okay, of course I can give you an imaginary number to check. Give it maybe 2 centimeters and give it a try. You can try to add it. Now, but I'm going to show you this. That they share the same parameter. Now, to explain this further, or to convince you that it is such, I bought some pipe cleaners here. Okay, you can buy them from bookstores, online as well. And I find it's really very useful. You can use this since it has many purposes. And some of us may have seen this already in school. And in fact, you can use this to learn many things. And some of us, when you are in kindergarten, you might be using lots of this to develop fine motor skills. So what I'm doing here is I'm going to outline this square with my pipe cleaner, and you see I'm teaching you how to do things with various tools, and I will very much hope that you enjoy doing the activities as well if you are able to find the materials. Okay, so I've outlined the shape here. I'm going to snip it over here. Okay, so I have this shape now. There's the square. Okay, and I come to here, this point, and I pull it out. That's that parameter. You can see the 4 sides of the square. 1 side, 2 side, 3 and 4. 4 sides of the square. And I join them up together. Oops, a little bit of the orange. Okay, that's the square. Now coming to this, if I have to bend this a little to make into the shape, as if I cut that square out, right? Can you see that? So it's the exact same pipe cleaner, orange wire I used. See? The parameter has not changed. It's bending the 2 sides of the square outwards. See? So I bend the square outside. See? And here, because it's a small square, the sides are the same. And what I did was I just bend it in to form the L-shaped figure. And there you go. The parameter is unchanged. Now, like I said, the main biggest reason is to understand that you're looking at the parameter of the figure. That's the outside of the shape, and that for this it has not changed. So likewise, like I said just now, so to answer this question, the parameter of the figure is the same as the parameter of the 10 centimeter square. So it's actually just 4 times 10 centimeters, and that would be 40 centimeters. That's all. Now, to help you feel convinced with this, so I've done my raised steps. Remember to take it off the annotation. To help you to understand a bit better, let me give this this imaginary shape a number. Square. So if it's let's say 2 centimeters aside, that this missing portion would be 8 centimeters. And I just add up. Be very careful. I can't be adding these 2 sides because these 2 sides are cut off from the shape. and I go ahead and do the addition. 8 centimeters plus 2 centimeters plus 2 centimeters plus 8 centimeters plus 10 centimeters plus 10 centimeters. So I give it an imaginary number, but it's part of the side stereo, of course, because I cut it out. So this shortened side became 8 centimeters. I got 8 because it's 10 minus 2 of the small square. So you add up the numbers, you realize that, hey, it's still the same. You end up with the same answer. Okay, so I'm using this step to prove why it works, as well as using the pipeline here to help you. Okay, and finally check whether you have indicated the correct units. It's 10 centimeters here. It's 40 centimeters here. Okay, and so that's question 2. I hope that this explanation has helped you.